This problem looks difficult, but you'll see how it collapses down really nicely and simplifies once I show you today on High Peak Education. Don't think of complex to necessarily mean difficult. Think of it as like one within another. Again, it's copy dot flip. It's the special case of clever negative number reverse factoring. You'll see what that means in a moment. That's today on High Peak Education. Here we go. What kind of fraction is this for number 2? Complex. Don't think of complex to necessarily mean difficult. Think of it as like one within another, like an apartment complex. One dwelling within a larger building. The idea is that when we have a complex fraction, do we want to leave it in standard form of the polynomials, or do we want to consider that they might be factored?
We want to factor them out.
That's right. Let's take it a step further. We also know ultimately with complex fractions, when we divide by the fraction below, it is correctly assessed by multiplying by the
Reciprocal.
right. What we're going to do is we're going to take this top fraction and we want to factor it. Now, 12x to the third, does that need to be factored on? No, I don't think so. So 12x to the third, I think, is our numerator. How about our denominator? What does that factor to?
I'm thinking multiple of 5 times 9, so...
Yeah, 9 and 5. So again, this is like our numerator. But then for our denominator, again, it's copy dot flip. So we can do dot flip of the factored form. That's what we're going to do. So dot meaning multiply. Then let's get a fraction going here. Now, the numerator is going to be what was the denominator. So I think that was x squared plus 7x minus 18. So what does that factor to?
X plus 9 and then x minus 2.
Gorgeous. And then remember, whenever we have something like that, where maybe we only have 2 terms or both the terms share an x, we're thinking about greatest. Yes, and then what would the greatest common factor of that be? Exactly. Okay, so hopefully we have this as structured well as we can tell, right? Factor and recopy the numerator, multiply the dot flip of the denominator.
Now we cancel out the x minus 2 on the top and bottom.
Yep, of that second fraction. What else? I'd say we can cancel 2, because there's like an x squared here, and there's an x cubed here. So I think that we can cancel out x to the power 2. Then, what about the x plus 9s?
Yeah, those cancel.
And I think there's one more little thing. Yeah, 3 and 12.
You're left with 4.
Right, 4 up here, right? 4x over x plus 5. No parentheses even needed, right? And that'd be our answer. Hey, thanks for checking out High Peak Education. Do you need some one-on-one guidance? Go to our Calendly link and book a grade boost game plan. Or if you're studying for a standardized test, for a score soar game plan. At highpeakeducation.com, you can click book now or see our Calendly page. Okay, let's get back to today's video. So there's a bit of a special rule. Suppose you had something like this. This is kind of the special case of clever negative number reverse factoring. Here's an important thing. Do you notice, is this 3x and this x plus 1 gonna possibly cancel? Right, it's just a product of 3 and x. X plus 1 has a plus in it, so no way. Also, do you notice these aren't going to cancel, nor are these going to cancel with each other? But I want you to notice that, again, I'm using the highlighter. Do you see how these two terms look super similar? I want you to notice that these two terms look very similar, but they are reversed direction in terms of the subtraction. Would you agree? So I want you to recall something. Suppose I have simply x minus y. If I factor out a negative 1, could I make that negative x plus y? Could I do that?
Oh, well, the negatives would cancel each other out.
Yeah.
On the x, and then it would become a negative on the y. So yeah, it would equal the same.
But notice something. I want you to, this is an important notice. Typically, we don't write the number -1. We just write negative when we factor out a negative. And negative x plus y, we can reverse the direction because we usually put the positive number in front and the minusing towards the back. So another way to write this would be negative on the outside, y minus x. So here's an important learning. This is like the key idea I want you to get out of this. Factoring out a negative turns a subtraction around. So if that's a rule we could use, consider the two terms that are in highlight. Usually we want x to come first. So I'd like to make the 5 minus x look like x minus 5, and then I could get some cancellation. So I need to factor out a negative. So what I'm gonna do is I'm gonna leverage the fact that I know I can do this. And so let's do that on this term. You follow me? Okay, so we're still gonna have the first fraction is the same, but let's factor out a negative, and we're gonna have negative parentheses x minus 5 and close it off. Do you see what happened?
Yeah.
And now we're in business, because what can we do with the x minus 5s? And then for the final result, we're just gonna have, now negative could go on the 3x, it could also go out front, doesn't really matter. So effectively, the final answer is going to be negative out the front, 3x over x plus 1. And you see that's going to be the final answer because the x minus 5s were able to cancel. So this is definitely one of those detailed skills from algebra that some students miss as they go along. And this is sort of the phrase I'd recommend you kind of digest. Factoring out a negative turns a subtraction around. You can always effectively turn that subtraction around if you want to, if you factor out a minus. Again, the reason we use that when we multiply rational functions is because we want to get binomials to match, so we can cancel.